Okay, today we're going to do the Snap Circuits projects number 5 and 6. We're going to talk about series. We'll build a series circuit, and then we're going to build a parallel. The things you will need is going to be your battery, of course your circuit board. You're going to need the L1 light. You're going to need the M1 motor. You need a little fan blade here. We'll sit that on top just like that. And we're going to do our S1 switch. Okay. Now this switch has created an open in the circuit. See, it's not making contact. If you look right here, this is showing the switch at rest. So it's not making a full contact. When you close it, it makes full contact and then the circuit comes alive. So it's a complete circuit. So when a circuit is broken, it's an open circuit. When a circuit is fully functioning, and then it's a closed circuit. Okay. All right. So this motor takes a lot of the amperage, and this little light doesn't take a whole lot. And most of the amperage are going to go to this motor. But I want you to watch this. When you turn this switch on, it has to build up inertia, and it's bright at first, but then it gets dimmer. So see, it's turn the switch on. See, it's bright, and then it gets dimmer. And the fans is spinning. Careful not to touch the fan or have any loose clothing or long hair. So right now, power is going from here, going through the motor, through the switch, through the light, through the switch, and back to negative. Okay. And that's a series circuit. So let's say this light bulb blew. Will this fan work? What do you think? It would not work because it's got to flow through that. If this fan motor blew, if something came in here, and let's say you're to disconnect this, okay? I'm going to create an open. I'll close my switch. It's not going to work. If I were to have a open before the switch, between the switch and the light, would not work because it needs a path for current to flow. All right. So that's a series circuit. Series circuits are pretty simple, and those are the ones that you like to start off on understanding. Okay. Now let's go to project number 6. All right, project number 6 says we need to take your S1 switch. I'm going to just kind of put that here. Okay, I'm not going to click it in yet. All right, I'm going to need the number 3 to go here. Switch can go on top. All right. Then I'm going to take my motor. It's going to go on here. I'm going to take my next number 3. I'm going to put it right here. Click it into place. Motor is going to go right here. Light bulb L1. It's going to go right here. Another number 3 goes right here. Now, when this switch turns on, what do you think is going to happen to that light bulb? What do you think is going to happen to the motor? So when you close the switch, in theory, everything should run fine. There should be a bright light and run at top speed. Let's see what happens. Now, I don't know if you can hear it in this video, but when you do this, you can tell that fan is running a lot faster and that light is a lot brighter because they don't have to share the power coming through. Because it has its own path to battery. So this one right here has power going to it and going right back here, and then the same amount of power is going to this fan and coming back and running through back to here. Again, if you were to have an open, so let's say let's say there's a wire, a mouse chew through the wire, and you turn your blower motor on for your car and it doesn't go, that's called an open. Now, a short, a lot of times people say, oh, it's got a short in it. Well, it could be a short to ground. And what that does, typically will blow a fuse when you have a short to ground. Turn your switch on and it blows a fuse. that's pretty much guarantee that you have a power wire going to ground before it goes through its load, whatever it's trying to power. All right. Now, let's take our voltmeter here. Let's see what we got. I got 2.63 volts. .59 volts. 2.59 volts. Okay. Click this off. Let's do that again. So now I basically created an open. All right. Should have 2.94 volts. And I go on this side, I have 0. I have 0 volts. I got voltage here, 0 volts here, because this switch is open. Voltage here, because the switch is closed. Makes a complete path for current to flow. Okay, that's a pretty good one there. Learn a little something about series circuits, and you learn a little something about parallel circuits. Stay tuned to the next video. Thanks for watching. Make sure you take a picture of your progress and submit it to me through Google Classroom, or through, you can email it to me if that's easier for you. And let me know if you have any questions.